Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for today's show. Thank you for joining me. Today on the show, I'm going to go through 3 different case studies that I've had doing some mobile work recently. I haven't had one of these episodes in a little while, so I like to get back to the bread and butter of the show every once in a while and just describe to everybody the challenges I'm going through on some broken vehicles and how we got to a solution one way or another. Today I've got a 2017 Ford F350 6.7 diesel that has a bunch of lights on the dash, limp mode, and what I end up finding is some communication issues with the diesel emissions system, which is kind of new to me. I have a 2014 Infiniti that has a convertible top issue that I ended up finding a pretty interesting fix or solution for this vehicle, and a 2007 Pontiac Grand Prix with a replacement ECM, or I should say ECMs, that we had some trouble programming and had to really go through it in order to get that one solved. But those are my case studies today. I'm going to go through those with you. Before we jump into the show, I wanted to let everybody know I recently became a top-down distributor. So you probably heard me mention the top-down scan tools once or twice on the show here. You've seen them on Facebook, other people using them. They've got a whole range of different tools. I personally use a couple of their different scan tools. I like their stuff. It's very reasonably priced. It's effective, fast. You know, don't get me wrong, there's not one scan tool that's going to do it all. There's not one that's better than all the rest, right? When anybody asks me or a lot of other people, you know, which scan tool is the best or which scan tool should I buy, you know, it's all of them, because you're going to need, there's going to be a hole to every tool, and that's just the reality of it. But that being said, I really do like these tools, and I think they're pretty reasonable for most repair shops and technicians, and that's why I ended up being a distributor, is because I was going shop to shop mobile, and I have people ask me all the time, you know, what scanner do I buy? What scanner do I buy? And there's a whole thing that goes into it that I don't want to get into right now, but I think what Top-Down has to offer can be very useful and profitable for a lot of shops. So anyways, that's why I ended up becoming a distributor, sell the tools. But here's the deal. Here's why I'm telling you about it. If somebody needs some top-down equipment, whether that be scan tool, battery charger, any of their other equipment that they offer, get a hold of me either through the email in the show notes or Messenger on Facebook, and I can get you a podcast discount. Just tell me you heard about this on the podcast. I can talk to you about any of the tools that you're interested in, and we'll get you a deal on it as a listener of the show. So with that out of the way, let's jump into today's episode. Like I mentioned, we are going to start off with a 2017 Ford F350 with a 6.7 liter diesel. I will start out by saying, and I probably said this before, I'm not a diesel guy. That is not my past in this field. Very sparsely did I do diesel work, occasionally. Probably lots of suspension, wheel bearings, ball joints, tires, axles, things like that. But the motor, the drivability, the performance side of things on diesels, I'm pretty weak, right? It's like welding. Yeah, I've done it, but am I great at it? No. I get the basics, but that's about it. So I let shops know this too if they call me on diesel stuff. And I'm up in the sticks here, so there are a lot of big diesel trucks. But I let them know, hey, diesel performance is not my expertise. And the other thing I run into, and I always ask them now, is it tuned, right? Because there just seems to be so many of these diesel trucks. If they're more than 10 years old, they've been deleted or tuned or combination thereof in some fashion. And then they're asking me to program something in or out or whatever. And I don't want to get involved in that, but that wasn't the case with this one. This one was all stock. Again, 2017, relatively low miles. But the shop said that the bunch of warning lights that come on the dash, that this truck had gone into some type of limp home mode, or at least that the customer was having difficulty driving the truck. And so that's why they brought it in, and they had scanned it. They had an array of codes, which this particular shop, who they actually work on a lot of diesel equipment. So it's kind of nice to call these guys for those things that I don't know about. They work on like forklifts and bobcats and all this other stuff, but they're not so great on the electrical network computer side of things. That's not their thing, right? We all have our specialties, and I think it's pretty effective to use other people who have a specialty that you don't share in order to get things done. And that's what we're doing there, right? He's calling me because he's like, hey, I don't know what these codes are about, because a lot of them actually were network codes. And so I come in, I verify, yeah, the bunch of lights are on. There's diesel emission warnings on the dash. Something about the DEF system, limited range or limited power on the dash. I didn't go through all the warnings. There was quite a few of them. But, of course, I want to scan it for codes, and I've already expecting to see some U codes or some sort of communication codes based on what the owner of the shop had told me. So I scan it using IDS, factory forward software, get all the codes. PCM's where I'm focused here, of course, because that's the computer that's going to be running the engine and the emission system for this diesel, and there are a ton of codes. I have communication codes. Number one, there's a communication U code. I think it's U0074 that says CAN bus 2 off. Which basically means that there's something wrong with the entire network on CAN bus 2. And at this point, I'm not really sure what that entails, but it's a 2017. This obviously does have multiple CAN networks, so I may have to dig into, okay, who's on what network and how does that all drive together. But continue reading the codes to help point me in a direction. I've got no communication, and again, this is in the PCM, no communication to the glow plug control module, to both of the NOx sensors. That's NOx, not knock, but NOx. And there's two of them in the exhaust. No communication to the particulate matter sensor / module. And then also a performance code or a low output code from the mass airflow sensor. Now, this wasn't a communication code, but it was in there for the mass airflow sensor. Okay, so we have all this stuff. Obviously seems like network issue. The PCM's not able to talk to certain things, but again, my problem is right off the bat as I'm sitting in the driver's seat of this truck is I really don't have a clue how a lot of this stuff works intricately, right? I have a basic idea of the diesel emission systems, but far from an expert on a 2017 6.7. I could count on one hand the amount of those that I've worked on. So I may have some learning to do before I jump into this, but I'm going to try to approach this and try to use the codes I have and the symptoms that I have to get to a point where I can do some testing, right, without spending a crazy amount of time trying to figure out the system. And my advantage here is that I do know network stuff really well, right? And that's where, kind of why I'm talking about this is, even if you're unfamiliar with a vehicle or a symptom, a lot of times you can take information you have from past experiences or other vehicles, and it can be applied. And that was definitely the case here. Even though I'm not an expert on the diesel side, the network stuff made this, it was actually fairly quick to get through this, considering that I'm kind of a newbie on the actual truck itself. So first thing I'm going to do is just look at some diagrams here to try to get an idea of the network construction, right? Anytime we got network codes, we got modules that we can't talk to, I want to see how is this arranged, how is it constructed, and of course we had that code for the CAN bus 2 off, so I'm going to look through the wiring diagrams to see if I can find and isolate just who's on CAN bus 2. And I do find that the redrawn diagrams were not very helpful in this case that I was using, but the factory diagram had a really nice one that had the entire network on one page. And I like that. There's some factory diagrams, and Ford's guilty of this in some cases too, where you have to page through several different pages to get the whole picture of the network. I like to see the entire network on one page if possible. I realize it's not always possible. Some cars just have too much on the network, but if I can get it all into one picture so I can get the whole scope of the network construction, I like that. And they had this for CAN bus 2. And just as the codes point to, this has got, of course, the PCM on this CAN bus. The PCM's on another network as well. That's how I'm able to talk to it with the scan tool. But on this CAN bus 2, there's glow plug control module. There's the two different NOx sensors, which it's sensor slash module. It does communicate on a CAN bus. Those are located in the exhaust. The particulate matter sensor slash module, and the reductant level sensor. And so that one, it said, or didn't list it specifically as a module, but as a level sensor. So those are the things on this. Actually, I should say those are the only things on this CAN bus 2. And of course, I have codes for all of them. There's also a code for mass airflow sensor, which I don't see on here. Typically, mass airflow sensors are not on a CAN bus. Doesn't mean they couldn't be. And there are instances where I've seen some mass airflow sensors use a very basic data communications. Newer GMs are like this, actually, where they're using a bidirectional messaging system between the mass airflow and the ECM. And if you unplug the mass airflow sensor on like a 19 Chevy truck, it'll set a loss of communication with the mass airflow sensor, right? So now we're putting a gray line between modules and sensors, right? But anyways, doesn't seem to be the case on this particular Ford, but I do still have that mass airflow sensor code. So I want to keep that in mind because I don't see that on this initial diagram, but I do have every other module. And so that with my U0074 sounds like this entire network's down. Like nobody can talk to each other and to the PCM, and that's why the PCM's setting this code and going into lit mode. Okay, so what's my next step here? Of course, before I really jump in deep, I want to check for TSBs, known problems. Didn't find anything for this. There was some hits on identifics for just a single module on this network being a no-com, like the glow plug control module or the NOx sensor, but not everything on the network. I didn't see anything that fit my symptoms with service bulletins or known problems. Okay, so we'll move on from there. And now I need to decide what type of test am I going to do to the system. I can't talk to anything, or I should say the PCM can't talk to anything. As far as I could tell, I didn't have a direct link to this CAN through my scan tool, but the PCM is on this network, and it can talk to those things, but in our instance, it can't. That's why it's set in the codes. So do I go to this network? Do I access it on the vehicle wherever I need to go? Do I scope it? Is it shorted? Is it open somewhere? Is it corrupted by one of the modules on the network? That's a possibility. But before I jumped into this, and again, I think this in the moment, it really had to do with the fact that I was unfamiliar with the vehicle. And I was like, I don't even necessarily know where these components are. Yeah, I could probably find the NOx sensors. They're going to be in the exhaust somewhere. But it's not like if I'm working on a gas Chevy truck and I just know where all these components are, I can jump in quick and do some tests. I was going to have to do a little bit of searching just to access something to get into it. So before I do that, before I even leave the driver's seat, I just want to check one more thing. I want to see, is there anything else that all of these components share that have in common? And if you're paying attention, which took me a couple looks to actually notice this and see it, I didn't see it right away. On the diagram for this CAN bus 2 and for these components, it actually shows you that one fuse, it's fuse 4, 20 amp fuse in the underhood fuse box, actually supplies power to all of these components that I mentioned earlier, right? So that's the NOx sensors, that's the glow plug module, that's the reductant level sensor, that's the particulate matter sensor module. All of them have a shared power source. And it branches off to another diagram, which I did a little bit of clicking, a couple clicks. I haven't gotten out of the seat yet, but I'm pressing buttons. I'm working real hard here. It goes to the mass airflow sensor too. Okay, so I'm feeling really good about this. And again, it was just a matter of really just kind of studying the diagram and, okay, I see a fuse, and I'm looking at this violet wire, and it goes to all of these. And now I have a really good feeling that I can go do a couple tests here and be on the right track. And I'm not even going to worry about scoping the module. I want to make sure that this power feed is good to all of these components. And especially because it included my mass airflow, which I have a code for as well. All right, so let's go check this out. Go under the hood, fuse 4, 20 amp. It's blown, it's popped. All right, cool. Do we throw another fuse in there? Before I do that, these are those little mini fuses, and I have some in my van, but I don't like wasting them if I don't need to. So I take a test light and I power up my test light. So the clip end of the test light goes onto the B plus side of the battery, and I put the other end in the test light on both sides of the fuse. And I don't know which is the power supply side of the fuse and which is the load side, but if I'm doing this, if I'm powering up my test light, the test light for this particular circuit should not light up brightly. Now there's examples where this may not be the case, depending on the circuit and the resistance in the circuit, but in this case, I would expect on the power side, the feed side of that fuse that's coming from the battery, the test light doesn't light at all, right? It's just going B plus to B plus. We wouldn't see any light from the test light. And if I'm on the load side of that fuse, I would expect that test light to light up a little bit, but be dimly lit, to be less than its full intensity, right? Because we've got resistance in that circuit before we get to ground, right? And so we're going to be running current through our test light, but it's got other resistors to go across as well. So the test light is going to be sharing the voltage in the system. It's going to be less brightly lit than it would be otherwise. That's what I expect. But in this case, because that fuse was popped, what I'm looking for is to see if the test light does light up with its full intensity. It means that the tip of that test light has a direct path to ground, right? Imagine if I just took the end of that test light and I stuck it to the negative side of the battery, it'd be the same thing. Test light would light up brightly. Well, I'm doing that to the load side of this fuse, and if it lights up brightly, that means that that load side of that fuse has got a straight shot to ground, and that's why the fuse most likely popped, because that's what the fuse is designed to do in that case. And of course, I touch that side, the test light does light up brightly, so I know I got a short to ground. Okay, so how do I find this? I've got 1, 2, 3, 4, 5, 6 components on this circuit. And much like dealing with a vehicle network or maybe like an interior lighting circuit, if you stretch this wire out, it's going to go, or this circuit out, it's going to go almost the length of the vehicle, right? We go up under the hood for the glow plug control module for the mass airflow sensor. We go down along the frame rail, underneath the vehicle, near the exhaust, to the reductant tank, that level sensor. And this is a large physical quantity of wire that I am now I shouldn't say suspecting, that I know has a short to ground, but I have to figure out where it is before I can put a fuse in there and recheck everything. So how do I find this? How do I make my life easy here to try to find this short to ground? Okay, I'm going to treat this just like I do with network diagnostics, right? With taking stuff that we're familiar with and applying it to other areas. And what I do in network diagnostics, where a network is shorted or corrupted in some way, is I'm going to divide and conquer. I'm going to split that network up, or in this case, I'm splitting up that power feed. How am I going to do that? Take a look at that diagram, right? This diagram has been really helpful in this diagnosis. It showed me a lot, and it's going to continue to do so. I found connector C146, found the location of that. It's right under the PCM, and the PCM is stuck into the firewall on the passenger side of the vehicle, under the hood, of course, right near the underhood fuse block. So I didn't have to go too far. I find my C146, and I disconnect this. What this is going to do is now separate that violet wire that power supply circuit into two different sections for me. On one side, I have my fuse box where the fuse is, where my test light is, and I have a glow plug in the mass airflow. So you can kind of think everything under the hood. And then the other side of this connector is the two NOx sensors, particulate matter, and the reductant level sensor. Okay, so that's on the other side. So I unplug this connector and my test light goes out. It's no longer lit. It's not on. There might have been a little bit of a light to it. I didn't notice, but there was an obvious change, right? Our short to ground is now gone. Okay, so now I take my test light and I move it over to what I would call the frame rail side of C146, right? It's going to go down underneath the vehicle, and I connect it there, and it brightly lights, confirming that my short to ground is on that portion of the circuit, right? So now I've eliminated my glow plug module. I've eliminated any wiring under the hood, essentially, and the mass airflow sensor as well. None of that stuff is my short to ground. It's going to be underneath the vehicle. So I'm left with the two NOx sensors, the particulate matter and the reductant level sensor. Okay, cool. So how do I approach this? Do I want to find another connector? I looked, there was a couple of other connectors. They weren't going to be very effective in eliminating portions of the circuit, at least from what I could tell in the diagram. So at this point, I'm down to 4 different potential modules that could be causing it, right? Could be a wire too, but it could definitely be one of these modules. And so I'm just going to see if I can access any of these easily and try to unplug them specifically right at the component. And as luck would have it, one of these is very easy to get to. It's one of the NOx sensors. There's 2 of them. And one of them is bolted to the outside of the passenger frame rail, and very, very easy to get to. You lean down, you see it right there. And the wire goes up and around and into the sensor, which is actually in the exhaust. But the plug-in is on the outer portion of the frame rail. So I don't even have to get underneath the vehicle. I just have to kneel down. And so I'm like, well, this, low-hanging fruit, right? This is too easy. I'm just going to unplug this. And I take a peek of it, my test light went out when I unplugged this one. So I got super, super lucky that it was my first try rather than going around to all of them. Usually it's the last one that I do. That's how it normally works for me. But in this case, I was able to get it on the first try. So I plug in C146, I put a fuse in, I leave that NOx sensor unplugged, start the vehicle up, clear all the codes. Everything's back now. I got my mass airflow sensor. I've got communication with all the modules except for our NOx sensor 1.1. There's 1.1 and there's 1.2. The one I have unplugged, of course, there's still no communication, but the PCM can talk to the rest of the stuff. Okay, so the shop just needs to replace this NOx sensor module / sensor, and they'll be good to go. So that one was pretty straightforward, but the reason I want to talk about it is I just think it is important to remember, even if you're not super familiar with something, you can take information from past experiences on vehicles that might not even seem to be related, but they end up being related, right? My understanding of networks, my understanding of diagrams, that helped me to get through that one pretty quickly without much hassle. So fuse 4, underhood fuse block popped because of the NOx sensor module that's bolted to the outer portion of the passenger frame rail underneath the truck. So the next one is a 2014 Infiniti Q60. This is a hardtop convertible, and this is actually a technician at a shop that I go to that I do mobile work for. It's his personal vehicle. He asked if I could help him look at this, and he was going to pay me. I said, yeah, we'll take a look at it when we got time. And his issue was on the hardtop convertible portion. When he goes to open the convertible top, it will start the opening sequence, but at a certain point, even if you're pressing the button, it will stop. The convertible top will stop moving, and you have to let go of the button and cycle the key and then press the button again, and then it will continue the process, and eventually it will close. But every single time that he wants to open the top, he's got to stop, cycle the key, or cycle the push button ignition, and then continue the process. And it's a hassle, right? He doesn't want to do that. He just wants to be able to hit the button and get the top to close. So first thing, of course, I want to do is jump in and verify this. He was right on the money. He's a smart guy. He knows what he's doing. it did exactly what he said it did. Now, I should note, because you can't see this vehicle right now, if you haven't seen one of these things, maybe I'll include a video link in the show notes if I can find a good video of it. But this thing, man, this hardtop convertible, when it goes from the closed to the open position, there are so many moving pieces to make this thing happen. There's so many flaps and levers and mechanisms that all work together to make this happen. It's like a transformer. You know, like that's what I felt like when this thing was closing. There's just so many different things that are happening with this thing. But I did verify that it did exactly what he said that it did during this process. That you had to cycle the key because it just stops moving, and then you can continue it. All right, so first thing I'm going to do, code scan. Let's just see what codes are in there. There is actually a code in the convertible top module. So we want to take note of this because it's going to help us figure out what's going on with the system. Why is this thing just stopping? This is a B174B. The name of that code is parcel lid draw. That's what it said. Parcel lid draw phase 5 timeout. Okay. I don't know what any of that means. I don't know what parcel lid draw phase 5 timeout means, but that code's in there, and I did clear it. It came back as soon as I tried to open the top again. So this is a consistent code. All right, and so hopefully that'll help us figure out what's going on with this thing, but the definition sure didn't at all. I mean, and to be totally honest, I've never worked on this specific convertible top system at all. I've definitely seen a few of them. I get the idea behind it, but I've not dealt with an Infiniti convertible system before, or Nissan convertible system before. So I'm unfamiliar with the code, unfamiliar with exactly how the system works. Before I jump in too deep on this one, I'm going to do the same thing I did on the Ford. I'm going to search for TSBs and known problems on this vehicle to see if there's something that I can skip ahead to try, or some information that'll be helpful in figuring out what's wrong. Now, I did actually find a service bulletin that had very similar issues as to what I was having, where the convertible top would stop at certain points during opening and closing. And the fix for this was to go through a lengthy PDF that walks you through a process. The process actually isn't that long, but they sure draw it out in the PDF. It's a very, I don't know how many pages, but you got to go through quite a bit to read all of this. But basically it's a relearn process. You'll go through it, use the scan tool, and there's a disconnection of the battery at one point or another. There's a reset, and then you're going to go through some steps of opening and closing the roof of the vehicle in order to learn. And this is supposed to get rid of this. They did mention in the TSB, the reason that this happens is low voltage most of the time. So battery died or switched over. So I tried this twice and it didn't change anything for me. I had the exact same problem, the exact same code, even after the relearn process. And again, I did it 2 times. Okay, so at least we tried, we got that out of the way, and that didn't fix it. So let's read up on this code and figure out what they're trying to tell us with the definition. As it turns out, this code pertains to what they call a parcel lid, or some of them call them a parcel tray. And this is just basically just a panel that's going to cover the trunk area, if you want to consider it that, right? If you're standing at the back of the vehicle and you look in through the rear window when the roof is closed, you'll see a fabric covering over the trunk area. Okay, that's our parcel lid. Now, this parcel lid, when you go to activate or begin the roof opening, this lid is going to move up and down. And in the code description, where they say parcel lid draw, specifically the draw portion refers to up and down. Okay, so when I say draw, that's Nissan's definition for up and down of the parcel lid. So if you imagine you're looking inside the rear window of the Infiniti. Sorry, I put together Nissan and Infiniti a lot of times, so I apologize if I say both, but I mean the same vehicle. You look in the back window of this Infiniti and you begin the roof opening, you would see this lid or this tray drop down towards the bottom of the trunk. And that's the normal operation for this. But they consider that movement, the up and down movement, to be draw. Okay. Now, further into the opening of the roof, this lid actually rotates to the vertical position, right? So it's in a horizontal position originally. It's covering the trunk area, and at a certain point it moves to a vertical position. I'll definitely try to find a video of this so that you can see what I'm talking about. It kind of helps you understand the movement here. So it also has some rotational aspect to it. But again, and reading this stuff, reading the description operation for the system, reading through the codes, really does help you understand what they're trying to tell you in the code definition. Even though it might seem like gibberish at first, there is some meaning behind it. So this parcel lid draw phase 5 timeout. That's the last part that I don't quite understand yet. But again, through digging, through reading the code, I find out that the convertible top control module is actually watching this parcel lid to see where it's at in different phases of the draw or the up and down movement. Okay. Now, this is something that I really had to dig to find because it wasn't in the code information. You have to go into the description operation of the convertible top system. There are 6 different phases for this parcel lid in the up and down range. All right. And the code mentions phase 5. Phase 2 is when the lid is at the top. Now, why phase 1? I don't know. But phase 2 is when this lid is at the very top position. This would be roof closed in its normal status, and that tray is up and is covering the trunk area. Phase 6 would be the opposite end. This would be when the lid is all the way down, basically flush with the trunk level, sitting on the trunk fabric, right, or the floor of the trunk. And so if you were to look in the window, now that lid is all the way down. Okay, and so different phases. So as the lid moves upwards, the phase number goes down, goes from 6 up to 2. Now it's saying phase 5 timeout, and in the code description it says the computer has determined that phase 5 took too long to move past, or didn't move past phase 5 at all. Meaning to me that this thing's getting jammed up or it's not moving to where it needs to be. Now, I did a visual a couple times of this thing opening and closing, and it looks like this trunk lid goes all the way down. But let's take a look at the scan tool and see what's going on in the scanner. Does the scanner reflect what I'm seeing with my eyes? Okay, so I watch with the scan tool, and you can look at all of this stuff in the data stream, which is really helpful. As long as you understand it, all of the information is there for you. So I watch the parcel lid go down, and I'm watching on the scan tool, and I go all the way from phase 2 to phase 6, which is the bottom, which is where we want to go before it will move on to the next stage of roof opening, right? The computer wants to see that lid has moved to phase 6 before it goes on to the next step. And it just so happens that is when the roof operation actually stops. So the roof has begun to open as the tray is moving down, but the computer sets this code for phase 5 timeout, and then everything stops. But if you cycle the key and you press the button again, it keeps moving. Now, the interesting thing here is on the scan tool, even before the operation stopped, the roof has begun to open, the lid's moving down, it goes to phase 6 in the scan tool. To me, what I can tell visually and what I see on the scan tool is that this lid goes all the way down, goes to phase 6. But again, we're getting this code for phase 5 timeout. The other thing that I did try here was that you actually had a bidirectional control in the scan tool itself to command the lid to different positions. So you could go 2, 3, 4, 5, 6. And I was really working with between 5 and 6 to see, is there any issues here? And I'm watching it on the scan tool. I'm watching it with my eyes. I don't see anything. And we looked in the trunk. There's nothing that we could see blocking the lid. It's completely empty down there. Nothing looks bent. Everything's moving, at least from what I can tell, correctly to the right position. And it's showing us phase 6 on the scan tool. It's not like it can't get there. It's not like it's not showing it. So I'm not really sure what the computer's unhappy about. But again, going back to the code, it's specifying that it's taking too long to move out from phase 5, trying to go to phase 6, which is all the way to the bottom. Okay. So my next question here then is, how is the computer actually determining the position of this parcel tray? I want to understand how the system works, and then maybe I can run some more tests. I'm not exactly sure which direction I'm going to go. I'm thinking maybe I'll test this sensor. Maybe it's a Hall effect sensor or something like that. But I've got to at least understand how the computer is making this determination before I can move on with any other tests. So I figured this out by looking at the diagram again. Sometimes the diagram is really helpful if they don't include this in the service information, but I found out the sensor for the draw state of this parcel lid, the up and down movement. The position sensor is a 2-wire digital sensor that's built into the motor that moves this thing up and down, right? And I'm like, all right, cool. I'm going to scope this thing, or at least get a visual on it, maybe watch this motor, see what's happening. Maybe something's binding up. Maybe there's an intermittent signal. I don't know, but I got to do something. So I'm going to go to this component and see what I can do for testing. So in order to access this, I've got to take the carpet up in the trunk. There's that panel over there's like a little luggage compartment there and everything, but you have to take this plastic panel and fabric up from the floor of the trunk. And then there's a plastic panel that goes over the frame for this parcel lid, right? So if you imagine I'm in the trunk, I'm looking at the back seat of the car, there's a metal frame that goes around the outer portion of the back seat, and that is the frame that this parcel lid actually moves up and down on. And it's got 2 threaded pieces, one on each side, so that this thing can actually move up and down. The motor is in the bottom center portion of this frame, and it's connected to each side with 2 cables, okay? So I want to get to this motor. I take some things apart. In doing this, and this is where I found my problem, as soon as I took this apart, this was a visual inspection win, right? I didn't even get a chance to get my scope out and test stuff. Didn't need to. Once I took the plastic cover off of this metal frame on the bottom portion, on the driver's side of the vehicle, as this parcel lid moves up and down, there's a stopper that's connected to the bottom of the tray, right? So the bottom of the tray comes down, the stopper hits the trunk area before anything else does. But it actually goes down into a hole in this plastic cover, right? So there's a rubber stopper, it goes into a hole and stops on something down in there. It's actually the frame. And so when it hits this, that's where the lid will stop, and that should be phase 6, right? That's phase 6 right there. Well, after I removed the plastic covering to this, I could see down into where this stopper went to, where this stopper was supposed to hit. And it's a circle. It's maybe 1.5 inches wide. And inside of there's a lug nut just sitting there on the frame. And you could tell this lug nut had been pressed on. You could see the marking on the lug nut. You can see the marking below it, that it's been sitting there for a little while. And when the lid came down and it went down into this hole, which you couldn't see what was down in there unless you removed this plastic thing, it hit the lug nut and was not able to travel any further down. Now, interestingly enough, on the scan tool, it still showed that this thing reached phase 6 of movement, but because of that lug nut obstruction for the stopper, it must have been keeping this thing from reaching it in a fast enough time. There must have just been that amount of hang up before it determined that, oh, okay, I'm in phase 6 now. Or maybe there was like a little bit of stretch in the cable that motor was connected to that allowed it to think, okay, I'm stretching, now I'm in phase 6, and that was the timeout portion, right? So as soon as I saw this lug nut, it made sense. And we'd looked for an obstruction, but honestly, you couldn't see anything if you just looked in the trunk. It was completely clear. Well, this lug nut had fallen down in, somehow or another, he had a lug nut rolling around in his trunk, had fallen down into this hole, and then when the stopper came down, hit the lug nut, set the code, prevented the top from moving. So we took the lug nut out, and that fixed it. The code went away, and the roof moved the way that it was supposed to. So it's back to transformer mode, and we're good to go on that one. So I just thought that was pretty interesting. I learned a lot about that system that I didn't know before, but visual inspection for the win. And who knows if I'll ever run into that scenario again, but that's the first thing I'm checking if I have a convertible issue Check for physical obstructions. And I could say that's even true for sunroofs. I've run into that with sunroofs as well before, where there's obstructions in the track, and that's what keeps them from fully opening or closing properly. All right, last one I got for you is a 2007 Pontiac Grand Prix. This one's a little bit of programming stuff here, but I had some issues. Again, 2007 with a 3.8 liter V6, could hold 3,800. This is a transmission shop that I do a lot of programming for. They're a pretty sharp shop. They know what they're doing. They're usually pretty accurate. If they tell me, okay, this is what's wrong, we replaced this module, can you program it for us? From what I found, they're pretty accurate. I mean, everybody makes mistakes, but I gauge shops when I go, like, are these guys just launching parts at something, or are they actually doing some testing? And in this case, this shop does some tests, and they'll actually tell me, I did these tests, and here's how I came to my conclusion. And I like that. That's awesome. That's good for me to know when I'm jumping into something. But they replaced the ECM, or I should say the PCM, powertrain control module, on this Grand Prix. Now, they did mention that's not why it came to the shop. It actually came to the shop to do a transmission. It's a transmission shop. And after they put the transmission in, it wouldn't crank. And they determined through diagnosing that the powertrain control module is faulty. Said no communication with it. They told me we checked powers, we checked the ground, and we checked the communication best we could. I don't know if they have a scope or not. I didn't get into those details, but they said they checked all this stuff. And again, I trust the shop that they actually did those checks. Okay, cool. Well, I'll program it for you. So hook up to the vehicle, and I immediately have an issue. It wouldn't ID the vehicle. Okay. Now, I forgot to mention this is a used ECM in this vehicle that they put in. Maybe with a blank service module, that might be the case where there's no VIN in it. So on this GM, our scan tool, our programming device, it pulls the VIN from the PCM, powertrain control module. And maybe if it didn't have a VIN in it, I could see why we wouldn't auto ID, but it's a used module. We should have a VIN in there. We should be able to pull it somehow or another. And I noticed right away that I had to punch the VIN in manually. And then when I went to actually program the PCM, SPS2, which is GM's programming system, attempts to communicate with the existing module on the car in order to get calibration info, not only from the module, but from the server as well. And so it's going to make that communication with the module. And it's nice, SPS will show you, here's the current calibration in the module, and here's what the updated version is, and what you're going to be programming into this module. Well, again, immediate issue, SPS2 said, I'm not able to get any information from this module. And right away, that's indicating to me no communication, which, according to the shop, was the issue that they were having. Okay, well, before I go up front, let me just check a couple other things. I tried 2 other scan tools just to see. I tried a Tech 2 and a launch scan tool. It's just what I had handy. Of course, the Tech 2 is the factory tool for this vehicle. Neither one of these could communicate with the PCM as far as identifying VIN, getting a data stream, anything like that. Now, curiously enough, I did happen to check for codes in the PCM. I was able to get codes out of this thing. I had an oxygen sensor circuit code and a theft deterrent code, and that's to be expected. It's a used module in a car that has an anti-theft system. I did find that kind of strange that I could get codes out of this thing, but I couldn't get any module information. I couldn't get any data stream. It's like it was talking, but it wasn't fully talking. It's really strange that I get codes, but nothing else. But anyways, I'm not there for a diagnosis at this point. At this point, I'm just trying to program, but I want to be able to tell him, okay, this is where you're at. How do we want to proceed? So I go up front, I tell him, hey, my programming device will not communicate with this module. My scan tools will only pull codes and nothing else. Literally nothing else works. How do you want me to proceed with this? Because I'm not going to be able to program it if my device can't communicate with it. And I did mention, I was like, if communication was your issue before, this might be a built-in problem. He's like, yeah, it's possible. We did our checks, but why don't you go through yours? We'll pay you. And just let us know for sure that, maybe there's another issue. Maybe it's a module issue. Okay. So I go through and I'm going to the module, which is in the airbox in this one. Really easy checks, right? There's two connectors. There's a blue one and a black one. There's one big ground pin, pin 73 on C2, the middle black connector. I got a good ground. Use a headlight bulb, lights up brightly, perfect. And they did say they checked this, and I believe them. Everything actually did check out okay here. Blue connector C1, pins 18, 19, and 20 are all power feeds to this module to basically power up. Where one's a constant power feed, two are switched. Two of those light up a bulb. One of them, which I think was pin 18, that's 12 volts. Keep in mind that will not light a test light. Reason being is that's a wake up feed from the BCM, and it's just a voltage, and the PCM just needs to see a voltage. And so if you use your test light, you'll actually pull that voltage down, and you'll kill that wake up circuit for a few other things too. Ask me how I know that. So anyways, on pin 18, you want to use either a scope or a meter to check for this voltage. A test light's not going to be effective there. But for the other two power feeds, I did have power. And for that circuit, I did have power on that as well. So I have my 3 power feeds and my 1 ground. And this module's simple. That's all it needs to turn on and start doing its things. The other thing, of course, is our communications line. And this is where it was a little interesting. I looked at the diagram, and I had an option for CAN bus, but only if the V8, the 5.3 was installed into this vehicle, which it was not. This is the 3.8 V6. And in the 3.8 V6 version, there was only a class 2 data communications line on pin 15, single line network communication. And that was it. And I checked that, good to go. All right, so where do I go from here? Got good powers, got good ground, got communication. That's all I need for this one to operate. Actually, I did check for a shorted 5-volt reference. I want to make sure that wasn't bringing down this module in some fashion. And there's 2 separate 5-volt reference circuits from what I could tell. They were both present actually, meaning that this module was receiving power and ground, and it was actually outputting 5 volts onto these circuits, right? That was there, it wasn't shorted. So I have, from what I can tell, everything that this module needs to be awake. Okay, now I do have this module in my hands at this point. My other consideration is this is a used module, and it could definitely be the wrong one. Now, again, good shop. They usually are pretty accurate in what they do, but that doesn't mean they can't get a wrong or even bad part, right? Could be wrong, could be bad. Let's take a look. And I grabbed the original one. He did still have that. I compared the part numbers on the sticker on the back of the module. And this is where you do need to pay attention. Well, spoiler alert for this one. This is where you really need to pay attention on these vehicles, this one in particular. There are 2 different numbers on the tag on the back of this ECM or PCM. There's a service number, which is on the bottom, and it says service number on it. The service number was the same. And if you look up this module for this vehicle, whether you're using Google or like carparts.com, or a lot of junkyards are going to use the same way, this service number basically gives you the physical item with the same plugins, but it's for multiple vehicles within a certain year range. Now, there's a top number on this. This top number is different between the 2 modules. And I think this is the actual part number for the ECM or PCM. This number was different. Now, I did just do a quick Google search on the number that I had on the used module to see, is this even for a Pontiac? It did come up as a powertrain control module for Pontiac 06, 07, 08 is what it said, and this one's an 07. Okay, well, maybe it's right. I don't know what it actually came out of. Again, the service number is the same, but that top number is different. But either way, at this point, I know that the module is either wrong or bad. I'm not 100% sure which. My gut feeling is telling me it's wrong, but it could be bad too. Could be a junk used module. That's possible. So at this point, I'm not going to go any further. I tell him, here's what I found. Everything on the car is good as far as I can tell, but I'm suspicious about the part number on this module. Again, weird that I can only get codes out of it, but something's up here. Why don't we verify that we get the correct module in this thing? Okay, he's fine with that. I'll get another module, and I'll give you a call. So he gives me a call. Next day, he finds another used module, and I don't know exactly why they're dead set on going used on this one. I don't know if new ones were unavailable. I don't know if they were trying to save money. That's not my thing. I'm just there to fix the car. So he gets another used module. I come in and I plug in, and it's the exact same scenario as before. I can get codes out of this thing, but nothing else. Nothing will identify it. I can't get a VIN out of it. There's no programming to be had. Exact same scenario with this module. Okay, so again, and he actually told me, he's like, they know that they got this out of a running vehicle. That's what he told me. Okay, well, I was like, did the part numbers match? Because that's what we're after. And I pulled this out, and they don't match. And it's different than the second one that I had. I'm like, oh, come on. You know, and then of course these plug in, they look the same. And again, that service number on the bottom's the same, but the top number is different. I plugged in this top number into a quick Google search, and it came up with a '08 Buick LaCrosse. And I should actually mention too, I looked on repairlinkshop.com. If you're not using that website, it's phenomenal for part numbers and VIN attributes, things like that. But I punched in my VIN information into RepairLink Shop, and it actually came up with a part number. It gave me that service number, which is at the bottom of the tag, that is the same across all three of these used modules. So unfortunately, that didn't really help me clue me into exactly what I needed for this vehicle. Of course, I'm assuming it's the original one's top number, but this one's different, and it says '08 LaCrosse. Now, here's my line of thinking here, is that an '08 LaCrosse is definitely a CAN bus vehicle, right? Meaning that 6 and 14 are going to be occupied on a DLC, and we're going to be talking on CAN. And maybe it's on the Class 2 as well, but it definitely is going to be a CAN vehicle. The EPA states that every vehicle in the U.S. built after '08 or, '08 and older has to talk on pins 6 and 14 for CAN bus powertrain communications, right? Now in an '07, they could, but that's not necessary. That's not always going to be there. And a quick look at the DLC confirms that to me, that the vehicle that I'm working on doesn't have CAN lines going to the DLC. 6 and 14 are empty. In fact, the only ones that are occupied on this DLC were 4, 5, 16, and 2. Okay, so 4 and 5 are ground, 16 is a power, 2 is our Class 2 data link, or our Class 2 data network. And that's all the communications on the car is happening on this Class 2 data line. And so now we've got a module in there that, according to the part number, I know has CAN going to it, or it's set up for CAN, but there's no CAN lines for us to talk to it on the car. And again, I can get codes from it, which is interesting, but nothing else. So what I did with this, I wanted to be sure, and he's paying me for what I'm doing here. I'm not doing this for free, but I want to be sure. So I grabbed my, the Go Diag breakout box, which is super handy for stuff like this. And I already knew the pins on the ECM for powers, ground. And then I looked up a '08 Buick LaCrosse, and I found the CAN lines, which are just pins 1 and 2 on C1. So easy to find. They even have the numbers on the module for the pinout, which makes this really easy. This took me 5 minutes, if that. So I plug into the CAN lines, connect that to my scan tool using the breakout box, put a power supply into the breakout box, and I can talk to this module now. I can ID it, I get a VIN, it says it's an '08 Buick LaCrosse, I can get data stream, all of that stuff. So where I'm going with this is, and I kind of had a gut feeling that this was it, the modules I got were wrong for this vehicle. Now, why could I get codes for these two modules plugged in the vehicle, but not anything else? Well, for whatever reason, and I couldn't tell you why this is set up this way, somebody smarter than me out there probably knows, the code information, diagnostic trouble codes, are communicated over the Class 2 data network, even on something that's set up for a CAN vehicle. That's how the information for DTCs is given, is over the Class 2 data network. But the rest, everything else, vehicle identification, programming, data stream, special functions, all that stuff is done over the CAN lines, which again, don't physically exist on the car, so we're never going to get that information. I benched it, I could talk to it, I got everything I needed, but those CAN lines don't exist on the vehicle, right? So we have to get the right module that's going to do everything through the Class 2 data line. as opposed to these other ones that do almost everything on the can except for codes. Again, strange, but that's the way it is. I think that one piece of info really threw me off on this. That I was like, I can talk to this thing, but not fully. Again, it's wrong module, and I kind of had that gut feeling going into it. But I mean, all in all, I got paid for several different trips of this vehicle, so it's not like it wasn't profitable. Definitely learned something. If I run into this again where I plug into something and I can only get codes and nothing else, I know it's the wrong module. But during this year period when they shifted from non-CAN to CAN vehicles, you have some of these modules physically the same plugins, same pinouts as far as the numbers go, same service number, which again, I think just refers to the physical item, not so much the what's at the board level. And that's where the difference is. How's that module set up to communicate with the car that it's plugged into? Which communication lines is actually using? So pay attention to that if you're buying used modules. Just because the junkyard says it's right for the vehicle, just because it fits, just because it plugs in, it does not mean that it's correct for the vehicle. You got to pay attention to stuff like that. Be as precise as possible when you're ordering used modules for vehicles, so that you can avoid these problems and avoid costing yourself in the programming side of things. All right. That's going to do it for today. Those are my 3 case studies. Thank you for listening. I hope you enjoyed that. I hope you learned something today. If you have any questions for me on anything, please feel free to reach out, comment on the Facebook group, anything like that. I love to hear from everybody. Feedback's awesome. Keep that up. Don't forget, I got all the links in the show notes to my email. If you got any questions on top-down scanners, I'll help you out there. You can send me feedback about the show. Maybe you want to be a guest on the show. My email's in there as well. Facebook group, the website, that's all there in the show notes of the podcast. Thank you so much for listening. But with that all out of the way, let's get out there and start fixing the world one car at a time.